Hello and good day, Algebra. We are continuing Unit 1, second objective, estimating the root of a non-perfect square. We talked about non-perfect squares in CO1. What is true about the root of a non-perfect square as far as rational and irrational is concerned? Aiden. Right. It's a non-perfect square because there's nothing times itself that equals it. You know, the example that we used yesterday was like the root of 12. You know, nothing times itself equals 12. That's why it's a non-perfect square. And as far as rational versus irrational, what's the root of 12? Which category was that fall into? Yeah, irrational, right? Because it's not a perfect square. Okay, so the definition of a root is essentially a number that, when multiplied by itself, equals a given number. Okay? A number that, when multiplied by itself, equals a given number. Yes, sir? Would 1 count as a perfect square? It is. Yep, because 1 times 1 equals 1. Yeah. So if I ask you for the root of 25, what number times itself equals 25? 5. Thank you, 5, right? So 5 would be the root of 25, okay? Now, we've talked about this in the 5-card challenge before. If you use a root in the 5-card challenge, what do you have to have up in this little check mark opening here as the degree of the root? You can't use a root unless you're able to use a, anyone remember? A 2, right? Because this is called a square root. And it's called a square root because we're asking what number times itself, what number squared equals 25. We don't write the 2 because it's just understood that the 2 is there, okay? But what that leads us to is that there are other types of roots other than just square roots, okay? If I ask you for the cubed root of 8, what I'm asking you for is what number times itself equals 8, right? What number cubed equals 8? Answer? Or no? Okay. Well, what would that be? What number cubed equals 8? Or what times itself times itself? 2, yeah, right? 2 times 2 times 2 equals 8, and that 3 tells us there are 3 roots to 8, and that's going to be 2. Up until now, you've always kind of, when you've used a root, it's always been the square root, right? 25 has 2 roots, 5 times 5. But at the end of this lesson, we're going to start to talk about other degrees of roots. The cube root of 8, I think, is on there. But that's why the 2 has to be there in the 5-card challenge, because there are other degrees that exist. So a root is simply anything that, when multiplied by itself, equals a given number. A perfect square, such as 25, is a number with whole roots. Okay? A number with whole roots, meaning that their roots are rational in connection to yesterday. 25 is a perfect square because the square root is 5. 5's whole. Root of 12 is a non-perfect square because its square root is a long, nasty decimal. Okay? It doesn't have a whole number root. So a number with an irrational root is a non-perfect square, such as the root of 12. And our focus today is going to be on the non-perfect squares, because our job will be to estimate what those values are. Most of you probably know, if I ask you for the root of 100, you can tell it's 10. Okay? But if I ask you for the root of 53, well, might have to think about that a little bit longer. Our goal today is going to be to estimate that. Okay. I'm going to scroll down so I can do this table as well as the examples here. But anyone need the definitions yet? Anyone still writing? Okay. Good? All right. You can watch the video and pause it, and don't forget to like and subscribe. Okay. So going down a little bit here, filling out this table, talking about perfect squares and their roots. The first perfect square, Aiden already brought it up, is 1. What is the square root of 1? 1. Okay. The next perfect square is 4. What's the root of 4? 2. And then we've got 9. The root of 9 is 3. And then 16, the root of 16 is 4. And then 25, 5. And then 36 with 6. And then 49, which is root 49 is 7. And then 64. Yes, the root of 64 is 8. Good, good, good. And then 81, which is 9. 100, which is 10. 121, 11. 144. This next one's a highway that many of you probably take to get here in the morning. 169, which is 13. No. 14 squared is 196. And then 15 squared? 225. Okay. Now, you will not be able to use a calculator on this section of the test. However, hold on. However, this table being under a definition heading, you can put this on a help sheet. Okay. So if you don't know what these perfect squares are and you're worried about the non-calculator, you can put this on a help sheet. You just have to remember to actually do it. Okay. If you come in with no help sheet or forget to put it on there, well, then that's kind of on you. Yeah. Yes. This entire table here with the perfect squares and the roots and the definitions, yeah, you just can't put the Mr. Happy Pencil because those are worked out examples.
But can you draw Mr. Happy Pencil?
You can draw one, but you can't put anything next to it. No. Okay. Okay. So let's practice some here. Let's take something like the root of 70. Okay. If I ask you for the square root of 70, your first task would be to look and say, is 70 a perfect square? It is not. Okay. So then you look for, okay, what numbers do we know the root of 70 is between? 8 and 9. And we know that because the next smallest perfect square is 64, which is 8. The next largest perfect square is 81, which is 9. Which means that because 70 is between 64 and 81, it has to be between 8 and 9. So if we visualize kind of an imaginary number line there and mark half, and here's 8.5, which side of 8.5 will the root 70 be on? Will it be less than 8.5 or will it be greater than 8.5? Why say that? You're right. You're right. Exactly. Because 70 is closer to 64, it's only 6 versus 11 from 81. It's closer to 64, therefore it's going to be closer to 8. That's just whatever is going on, it's got to stop. Okay. So I would accept something like 8.2, 8.3, even 8.4. You know, you're on the correct side of half. It's just an estimation, and so any of those would be fine. All right? Questions on that? Okay? So you're looking for what two perfect squares is it between to get your number range, and then which side of half, which one will be closer to. Let's do the root of 157. Not a perfect square. However, what two numbers do we know it's going to be between? Let's build our range here. John?
12, 15.
Very good. 12 and 13. Because the next smallest perfect square is 144, which is 12. And the next largest perfect square is 169, which is 13. So making our little imaginary number line here, marking it half. Is it going to be closer to 12 or closer to 13? How far away is 157 from 144? Got 13 away here. And 12 away here. So what would be some acceptable answers here? Go ahead. 12.7. It is closer. You know, it is technically closer to 169. So I would take 12.7. I would also accept. I would accept 12.6. In this case, I would even accept 12.5 as well, just because it is just a difference of 1. You know, it's pretty much in the middle, about as close as you can get to the middle. So any of those three answers would be fine. I would not accept 12.4, because 12.4, you are saying that it's closer to 144, which it isn't, but it's pretty much in the middle, so 12.5 would be fine too. Okay? Questions on this? You do need to show the work when you're doing it on the homework. Obviously, you can just use a calculator to get the answer, which is why you can't use a calculator on the actual test. You can check your answer. Once you find it, you can plug the root in to see how close you are. Okay, but I need to see the work, and this is the work that I want to see. Something similar to this, where you're putting the next smallest perfect square, the next largest perfect square, getting that number range. Okay, that's what I want to see. All right. As far as how to check this in your calculator, G, can you hold up your calculator for the class to see? That's the recommended calculator for the course. If you've got a calculator similar to that one, this is how you take the root of a number if you don't already. Do you already know? Do I need to go over this? I feel like we talked about it last year, but in case we didn't. In the very top left of your calculator is a second button. It's probably a different color than the rest of the buttons there. That's kind of like a shift key. And you need that because your calculators can do so much. Notice how there are some things that are on the buttons themselves, and some things are written above the buttons, like on the actual plastic of the calculator. And if you look for the x squared button, which is kind of near your 7, I think up and to the left of the 7, x squared is written on the button itself, and then right above that on the calculator is the root symbol. So to access that root symbol, you first have to press that second function button. Okay? Yeah?
So will we put the number in and then do it?
No. So to start the root, you would press second, then x squared, and in your display, you should get this, the root symbol with a parenthesis given to you. Okay? Then you'll type the number that you want, 157 in this case. Close your parentheses and enter. And what do you get? You can see it's clearly irrational, right? That decimal goes on and on and on. But what do you get? 12 point what? Someone who has 12.5 given to okay, so we were right there. So to check your answer, this is how you do it. Second function, x squared button to get that root symbol, and then put in the number you want. Okay? Questions on this? Yes, Ifan.
Is this our homework?
So the rest of the objective is your homework. which is a page and a half to do. However, it's not due until Monday because tomorrow is the retake day. Okay, so this homework is not due until Monday, but yes, it's the rest of CO2. So you've got 4, like we just did, for you to practice on the first page. If you go to the second page, 8 to do here. You got more on the second page. And then the second Mr. Happy Pencil section kind of has you work backwards. It says, write the value of each decimal using a square root. And I give you the example of 7.1 would be approximately the root of 50. So what you're doing here is if I give you 4.5, you can think, okay, I know 4 is the root of 16. I know 5 is the root of 25. So what would 4.5 be? The root of what? What would you estimate? Right? If 4.5 is halfway between 4 and 4 is root 16, 5 is root 25, what would 4.5 be? The root of what? Yes, please do. What do you think? 20, sure. Or 21, right? Something that's going to be halfway between 16 and 25. So this section here is working backwards from what you did previously, to where I gave you the root, you gave me the decimal. Now I'm giving you the decimal, you work backwards to give me the original root. Okay? How about 6.8? 6.8 is between 6 and 7. 6 is equivalent to the root of 36. 7 is equivalent to the root of 49. 6.8 is almost 7. So our root is going to be almost 49, but what would you estimate that to be? What do you think? The answer is here. You're telling me what root is equivalent to 4.5. So if 6.8 is between 6 and 6 is equivalent to the root of 36, 7 is equivalent to the root of 49, 6.8 is closer to 7, so we know it's going to be close to 49. What would you think? Sure. Oh, well, sorry, Sasha. Sure, root of 45. Okay, root of 46, root of 44, right? It's working backwards from what we did. Okay. Then a few word problems for you. Through your grandparents, you find out your family owns a large plot of land in rural Minnesota. An old map they have shows the plot to be a square with an area of 200 square miles. The length and width of the plot have faded. Approximately how many miles long and wide is the plot of land? So you've got this square, and you know the area is 200, and you're looking to find the length and the width, or the base and the height of this square. Now, what do we know about a square? I can label both of those just x because what do we know about a square? Aiden. All sides are the same. So the area of a square is one side squared, right? If one side length of the square is 4, you just multiply 4 by 4 to get 16 for the area. If one side of the square is 100, you multiply by 100 by 100, the area would be 10,000. Okay, so whatever the base is, the height's going to be the same, and the area is found by multiplying that times itself. So if we know the area is 200, and we want to find the length and the width, what are we going to have to do? Keeping in mind that this whole objective, the point was to find the root of a non-perfect square, what do you suppose we're going to have to do to calculate what x equals? Noah? Essentially take the square root of 200, right? Because as we learned about the order of operations before, roots and exponents are opposites. So if we're squaring x and we want to undo that to get x by itself, then the root of 200, that opposite operation, is going to equal what the length is, and subsequently the width also because it's a square. So same idea as what we were doing, but an actual real world example. You might find yourself doing this someday, and you'll thank me for showing you how. Next one, a square bulletin board has an area of 80 feet squared. Estimate the perimeter of the bulletin board. So same situation. We've got this square. We're given the area, and we need to figure out the length and the width so that we can ultimately get the perimeter. So it's one extra step from what you had to do the previous one. You're still finding the root of 80, right, to get what that length and the width would be, but then the extra step, use that to get the perimeter, that distance around. Then, a backyard in the shape of a square has 34 feet of fence surrounding it. What is the area of the yard? Again, dealing with a square. The fact that it has 34 feet of fence surrounding it, what does that value represent? Like what measurement is that? Area would be like inside. This is 34 feet of fence surrounding it. Perimeter. So here, you're given the perimeter of the yard, which is 34. Again, knowing it's a square, okay? Knowing that, use that information to get the area of it. So that's your final answer. If you're given the perimeter of a square, use that to find the area. And then here's where we get to those extra degrees of roots that we talked about earlier. The cubed root of 8 is the example here. That little number in that check mark space is how many roots it has. So the cubed root of 8 is 2, because 2, 2, and 2 equal 8. The cubed root of 27 means what times itself equals 27. The cubed root of 27. What number times itself equals 27? You found? 3 is correct. Okay, so the cubed root of 27 equals 3 because it takes 3 of them to get there. The fifth root of 32 means that we've got 5 roots now. Nope, we'll do that later. So what number times itself equals 32? 5 of what number all multiplied together make 32? 2, right? So the fifth root of 32 is 2 because 2 times 2 times 2 times 2 times 2 equals 32. We'll come back to these different degrees of roots like in objective 63 or something like that, maybe 61. But if you see them, here's a kind of background as to what they mean and what you would do to solve them. Okay? Long video today. I apologize for that, but there's a lot to cover. Like I said, this will not be due until Monday. And let me see if I remember how to pause this. Hold on. We're going to do that. Not sure if that paused or not. All right. Sorry for the, I don't think that's actually the pause button. I think that was all recorded. Okay. That's all you math.
Don't forget to like and subscribe.
Thanks.